Welcome back to part two of Epigenetics and Schizophrenia. We are continuing our discussion and moving on to what I think is the most exciting and important part, and that is how all these pieces of the puzzle fit together. So, how do prenatal diet, DNA methylation, and schizophrenia risk all kind of come together? So, if you remember what we talked about before, we talked about SAM donating a methyl group to cytosine as a way of DNA methylation repressing gene expression. Now, in order for this to happen, one carbon metabolism must occur. It's way too complicated to try to explain this in the presentation and the mechanics of it, but if you're really interested in it, the article by Kirkbride at the end of the presentation does a great job explaining this process, and you can really take a deep dive. What's important to note, however, is that in order for this one carbon metabolism to occur, micronutrients such as folate, vitamin D, and vitamin B12 must be relatively available. So, in order for one carbon metabolism to occur, there needs to be micronutrients, and in order for DNA methylation to occur, there needs to be one carbon metabolism, and in order for genes to be repressed, there needs to be DNA methylation. It's kind of a snowball effect of a lot of things depending on each other, but that's how the human body works. So if you look into the evidence of kind of where we figured this out, it's actually, interestingly enough, based on severe famine exposure. So there's two different famines that are looked at specifically, which is the Dutch hunger winter, which occurred from 1944 to 1945, and the Chinese famine, which occurred from 1959 to 1961. Now, essentially what they did is, obviously this isn't new data, so when patients were put into mental institutions for schizophrenia, or they were a lot of times screened before acceptance into the military, they looked at the individuals with schizophrenia symptoms and compared it to their birth years and birth months. What they found is that there was a twofold increase in risk of schizophrenia for individuals who were conceived or in early gestation at the height of the famine. The Chinese famine was a little bit more difficult because they just had the year, but 9 months out of 1 year is kind of makes sense that that's how that would work out. I think it's crazy. So, having kind of established that there are vitamins that are needed in order for gene repression or expression to occur, and the lack of this has an increased risk for schizophrenia, moves us on to looking at the difference in diets and what exactly the outcome of those two diets are. So first, we're going to look at a balanced or consistent diet. This that we're talking about right now is an example of within indirect epigenetics, which means we're looking at how a mother's actions during her pregnancy affect her child's future expression of his or her genes. Now, a mother with a balanced and consistent diet is getting all of the nutrients both her and her growing baby need. Oftentimes, pregnant moms need a lot more because, again, they're eating for two. So this means that the methylation for her and her child can occur properly, and the offspring will have no increased risk for schizophrenia as an adult. I did want to go over some foods that have vitamin B12 and folate in it to give you the kind of idea of diversity and whole food diet that is needed for an individual to get these essential nutrients. So vitamin B12 is mainly found in red meat, some kinds of fish like tuna and salmon, eggs, and many dairy products. Folate, which is also known as vitamin B9, is found in legumes, which are things like lentils, chickpeas, beans, peanuts. It's also found in eggs, leafy greens, and fruits like oranges, papaya, bananas, and avocados. And yes, I consider avocados a fruit. On the opposite end of the spectrum, we have individuals with inconsistent and poor diet. So this is another example of indirect epigenetics. So how the mom affects the baby while she's carrying the baby. In this particular instance, the mother does not provide her baby with enough nutrients while she is pregnant, so her child will have a difficult time methylating his or her DNA. This means that the child is at an increased risk for schizophrenia in adult life. However, the amount that it increases the risk can't really be determined because we don't know exactly if the mom is getting nutrients, how much she's getting, and how much that affects it, but we do know it has an effect. So what kind of diet would have this effect? Simply not getting enough food, starvation, which is what we talked about with the examples of the famine. But another way this can happen is having a diet with little diversity and, quote, empty calories. So I'm sure you've heard of empty calories before. It's a big thing that nutritionists talk about for people who have poor diet. And they're basically foods that have little to no vitamins or minerals or really do anything helpful for you besides give you carbs. So these are things like fast food, candy, soda, processed meats. So delicious foods, but not exactly healthy ones. Because these foods have little to no vitamins or minerals or anything good in them, the mom could be eating enough food, but her child could still be at a higher risk for schizophrenia.